Hello, precious friends. I hope I find you well today. Yeah, I'm a little bit tired, but I have to try and make sure that I fulfill the promise that I made in my previous video when I was conducting a lesson on triangles. I hope you have understood all the bolts and nuts for solving triangles from the video that you had been watching before, whereby we were introducing triangles as three-sided polygons that are divided into two classes, normally right-angled and non-right-angled triangles. And we remember also that we talked about the formulae or the rules that we use when we are solving any of those two types of triangles. And I'm going to just give you a clue by saying that we agree that when we are solving right-angled triangles, it's either we use the trig ratio rule or we use the Pythagoras rule. When we are solving non-right-angled triangles, it's either we use the sine rule or the cosine rule. This is what we have agreed in the previous video, but very unfortunate because of time, I didn't manage to get into questions. So this video is going to give you, enough examples on, the application of all those four rules. Let us not waste the time, but quickly jump into the questions. Okay, guys, if there be any disturbances, just forgive me here. I'm recording from home, so I have got my kid here at home, so sometimes there's some kind of disturbances that I also may not be able to control. Just forgive me. Okay, so what I want to say is this: we want to gather a few questions and then we will just do them together. All right, by the end of this video you must be able then to understand how do we apply the four rules that I gave you in the previous video. Stay tuned, let's get into it. I have got this question with me here. It's a very simple question, and when you look at it, you know already because of the 90 degrees angle that you are dealing with a right angled triangle. If you don't know how to differentiate between a right angled triangle and a non-right angled triangle, I think it's good time for you to do a review also on the previous video that shows the differences between a right angled triangle and a non-right angled triangle. So what you are going to do here at the moment is we are going to introduce three main stages on solving triangles. So let me put them on the screen, and we are going to be using those three stages throughout everything, because when you are attempting questions on triangles, those three stages are the main keys. So make sure that you know them and then you write them on the tablet of your heart. Okay, that's fine. Okay, so the three stages that we are going to follow are the ones that I've put here on the screen. Stage number one is you must be able to name the triangle in the question. Okay, and then number two, you must choose the right formula after naming. And then stage number three is when you're now doing substitution and solving. Let us look at how do we do that on a quick note. Okay, so likewise here the question I have is very simple. We are going to start by naming it. Okay, so when we are naming this question, it's very simple. Let us do that. You see, I said you had identified first that this is a right angled triangle. So after identifying that it's a right angled triangle, the first thing you are expected of doing is to identify the hypotenuse, and this is the hypotenuse, as we said, the side that's opposite the 90 degrees angle. So we name it hypotenuse. Oh, sorry. We name it hypotenuse. Okay. And then after identifying the hypotenuse, you need to find the opposite. That's what I said. So do we have the opposite side in our question? For us to be able to have the opposite, we must have an angle either here or here, because an opposite is born out of another interior angle, you know. So because here we don't have any interior angle inside, this tells us that we don't have the opposite, okay? This means that we cannot have the opposite because the mother of the opposite is not given in the question. So we are going to leave the question like that and say we don't have opposite. So when we don't have opposite, are we going to say that's the end of the story? No, that's not the end of the story. We said we try to use the rules of algebra, whereby we put, you know, letters of the alphabet on things that are not known. So meaning to say, on this side we can put a small letter A, and here we can put a small letter B. Since we don't know opposite, therefore we don't also know the adjacent. This means now, since we named these ones as A and B, we don't want confusion in mathematics. So let us not name this one as hypotenuse, okay? We are going to name it as C, so that we are using the same units of measurements, okay? So you see, because we don't have opposite, hypotenuse was costed to use the letter C. All right. So this is all about how we name triangles. I think I gave you also, you know, a clue on this in the previous video. Now, after naming my triangle, I have to choose which formula to use. We agreed that when we are dealing with right angle triangles, we usually, let me do this, okay? When we are dealing with right angled triangles, we agreed that there are formulae that we use. Let me just give you all those formulae. Okay, I think it's wise for us to avoid confusion, so I have put the stages here on the other side, okay? So what we are saying is we agree that when we have right angled triangles, we use either the trig ratio, okay, or we use the Pythagoras theorem or the Pythagoras rule. So if you have watched the previous video, you will see that because we have A, B, and C, automatically the formula that we are going to use for this triangle is what we call the Pythagoras rule. Okay, so when we are using the Pythagoras rule, we are going to do the following stages. We are going to write down the formula first, and then we will do the substitution. So let's go according to the stage. First stage, writing down the formula. C to the power 2 equals A to the power 2 plus B to the power 2. That's writing down the formula. And then after writing down the formula, now we are moving to the last stage, which is substituting and solving. So I want to say something about substituting. When we are substituting, then it means we are removing and replacing. Okay, that's what you call substitution, replacing, okay? So substitution is removing and replacing. So what are we going to do? We want to remove C from the formula and replace C. So we see that C here, he has got a number on each side, and that number is 5 meters. So we are going to remove C from the formula and replace C by 5. That's what we call substitution. Make sure you listen very carefully, because in the next examples I won't be doing those things like in this manner. I will be a little bit fast. So we are replacing C by 5 because they mean the same. C is hypotenuse, and then we replace it that way. So we put 5 here, and then squared equals, we want to replace A by what? Okay, on A there is a number that's there and it's 4, so we want to put a 4 here and then square it plus. And then what about B? On the side of B we see there is also something like a number, but there is a given value. It's not a number, it's a given value, and that is x, and then we are going to put a square. This is what you call substitution. So if you do your substitutions correctly, remember that you are only replacing the way they are, meaning to say the formula is still the same, but what's different is we replace the some things from the formula by the numbers that's in the question. I believe you have understood that clearly. All right, now when you are solving, I just want to say you use the rules of solving equations. Here it's a free dance. If you have been doing dancing, there is what they call a free dance, meaning to say you use any rule that you think of for solving equations. So here I'm just going to use what I find easy. So remember, you are no longer bound to copy from me now. You are bound to use your own strategies of solving equations depending on how you learned on solving equations. If you haven't solved equations, then you must watch a video that I've recorded, also is there on solving equations. You will see it, okay? But for now I'm going to solve in my own way. Let's go. So the way I'm solving here, let us say 5 squared is 25, okay? So we put a 25 is equals to 4 squared is 16, and then we say plus here x to the power 2. So the next thing is collection of like terms. So I have 25 minus 16 is equals to x to the power 2. Then finally, if I subtract these, I'll get a 9, and that is going to be equal to x to the power 2. All right, to remove the squares, I'm going to put my square roots so that I can cancel all that power. Okay, and I'll be left with x equals to square root of 9, that's 3, okay? All right, here it was supposed to be plus or minus 3, because each time I introduce a square root, I put a plus or minus. But here now, remember that length should be measured as a positive. We don't have negative lengths, so that means my answer becomes x equals 3, okay? Since here everything is in meters, don't forget to say 3 meters. So this is what you do, very simple, okay? And this marks the end of question 1, okay? I believe you found it easy. Let us move on and go to question 2. So question 2 is saying also find x. Let me also do the same thing here of carrying this guy to this point so that you won't be confused. We are going to be following these stages, that's why I have to just keep them, okay? So let us go on and do the question 2. First thing is naming. All right, so when you are naming, we are going to start with what? We are going to start with the hypotenuse. There we go. The opposite is here now, because since 60 is in, then 60 must give birth, okay? Because 90 gave birth to x, which is the hypotenuse, 60 must also give birth to this, side, okay? Because sides are made out of angles, so you need angles and then they will give you sides. It's just a little bit of a reverse, okay? So here, this means 60 gave birth to who? To opposite, okay? and then 90 gave birth to hypotenuse. Now that I have opposite and a hypotenuse, the remaining side is called the adjacent. Okay, all right, fine. So what we need to do is we need now to choose the formula. Automatically, when we have hypotenuse, opposite, and adjacent, the formula choice comes by what you call SOHCAHTOA. SOHCAHTOA. Okay. As I said, this means opposite of hypotenuse, adjacent of hypotenuse, opposite of adjacent. Okay. So this means here the real work is on choosing here which combination is in the question. So the question here, if we can look at it, it has got adjacent given as 5. The opposite is not given. And then hypotenuse is given as x. So that means our work is going to be based on hypotenuse and adjacent. So is it the first rule? No, because the first rule has got opposite and hypotenuse. Yet we need adjacent and hypotenuse. So the first one is condemned. Okay? Okay, and then the second one is saying cos is equal to adjacent over hypotenuse. So that means we are dealing with adjacent and hypotenuse. Oh, okay. So you see this one is matching with the question because it has got adjacent and it has got also hypotenuse. The question has got adjacent and hypotenuse. So this means we choose this one. Okay, let us just consider if also by chance maybe the third one will also get into it. We find that the third one has got opposite and adjacent. Okay, it has got opposite and adjacent, yet the question has got adjacent and opposite. So this means it is not meeting the requirements of the question. So the law that is meeting is CA over H, which means we have cos of theta is equivalent to adjacent A over hypotenuse. Okay, you know, for this question I may write it this way so that you won't get confused. Okay, so this means we have adjacent over hypotenuse, and then we go on now. What is theta? Theta is the angle, which is the second angle, right? So that means we are going to do substitution. Cos of 60 is equals to our adjacent is 5 and our hypotenuse is x. All right, so what you need to do is to put cos of 60 into the calculator. Okay, so what I'm going to do is to put the calculator on the screen, and then I write here cos of 60. Is that right? So I have cos 60. Okay, I close it. Now you see it is 0.5. Okay, so I'm going to put 0.5 on cos 60, and then I put here 5 over x. Now the next thing after this is I have to, you know, let me just put a line to show division here. Okay, I just want to show that there is a bit of division here. Okay, so what we need to do now is our working is coming to the point of when we will be having what? Okay, so that means here what we are going to do now with this question, we just make both sides fractions when we want to remove fractions, and then we cross multiply. That's the law of removing fractions. So we have 0.5x is equals to 5. Okay, and then now we divide here by 0.5 and then divide by 0.5, the law of removing coefficients. This means 0.5 cancels 0.5, you are left with x being equivalent to 10. Okay, 5 divided by 0.5 is 10. Okay, so this is how we solve it. Believe you have understood it well. Now what you need to do is to move to the third equation. Okay, so the third equation is going to use also similar stages. All right, so what you need to do is remember that you need to check on the type of triangle first. So this one is a right angle triangle. So naming it is very simple. Oh, sorry for the fact that I haven't put this thing. Sorry for that. I was thinking everything is in order. The question was supposed to be having this angle, because without this angle we cannot say we have a right angle triangle. Okay, so the first thing is we need to identify our hypotenuse, and then after having our hypotenuse, we just put it here and name it hypotenuse. We need to find if we have an opposite. Yes, because as long as there is theta, theta must give birth, okay, to opposite. Okay, so theta will bring opposite to life. Okay, so now we have opposite. Okay, after that, what's next? Okay, let me try and make it a little bit clear. Okay, yeah, so after that, what we need now is to have the left side, which is the adjacent. Okay, fine, so let us have this adjacent. Okay, so what is the choice of formula? Because we are done naming all the three sides and all the angles inside are named, so we are moving to what you call formula. So the formula that we are going to use is again SOHCAHTOA. Okay, and then after that, now we are going to let us divide this page, okay, and do our working on this separate part. So what we are going to do is quite easy. Okay, we are going to write down the formula, and if I can look, the question is given me here 13, which is the adjacent, and 26, which is the hypotenuse. Okay, so what I'm going to do, I need something that is adjacent and hypotenuse, that is cos again. So I have cos theta equals adjacent over hypotenuse, and then I have cos of theta. I don't know theta, that's why I'm putting theta there. What is my adjacent? Adjacent is written 13, and then what is my hypotenuse? My hypotenuse is written 26. Okay, and then cos of theta is equals to 13 over 26 is 0.5. Okay, and now when I'm here, I'm stuck because I must take this boy called cos and make him cross the equal sign. So there is a very simple rule that I want you guys to know, which says that if cos crosses the equal sign, is that right? It becomes its second function. All right, so when any trig crosses the equal sign, it becomes its second function. So cos crossing the equal sign becomes second function of cos, and then sine crossing the equal sign becomes second function of sine, and then when tan crosses the equal sign becomes second function of tan. This is the rule. Okay, so let us obey that rule by saying cos must cross the equal sign, so that we'll be left with only sine. Okay, so we'll continue in that manner. We'll be left with theta is equals to, and then we have here cos crossing the equal sign becomes second function cos 0.5. Okay, so now how do we put second function cos? Second function cos let me show you here by the calculator. So the calculator itself, it has got this button called shift. If you can see it, I think it's indicating well. Okay, it takes the second function of every button, meaning to say this is a down button and then the rest are on top. Okay, so meaning to say when you press shift, you are saying let us step down to the second step of every button. So this is why shift is in orange, and you find that everything that's on the cover of your calculator is in yellow, meaning to say you are stepping down from the button to the cover. Okay, so what we need to do is to use the button to step from the button to the cover. Let us do that. Okay, so what I'm going to do is I'm going to put my shift, meaning to say I'm stepping down from the button called cos. All right, that's how I put it. So I have now second function cos, is that right, of 0, 5, and then I close it. Okay, when I close it, I get the answer called 60. That means my angle theta becomes 60 degrees. Okay, I hope you found it very well and easy, you know, to do that. Okay, remember, when you want the second function, when you are using a sharp calculator, you use the button which is written 2ndf, okay, or 2nd, which is second function. And then if you are using a Casio calculator, you use shift. That's the difference. Shift and second function is one and the same thing, only that they use different, you know, languages. Okay, I believe you got it right. Let us move on to the next to the next question. Okay, all right, so the next question is saying find theta. Now this time around we are given a different type of a question. We have what you call a non-right angle triangle, meaning to say we want to learn how do we decide between the sine rule and the cosine rule. Okay, so here the first thing is to name, and how we choose the sine and the cosine. I think I haven't explained clearly in the previous video, so you need to listen very carefully. We take and choose the number of combinations, but remember that even though we are doing that, our rules here, our rules, we still take them. Okay, so I just want to have them with us. So when we are naming and choosing, we said that we must find a pair of corresponding angles and sides. So this means here, let every angle give birth right now. Angle code 65 is going to give birth to 5, and then angle theta is going to give birth to 7. Okay, so let's say if there are two beds, is that right? If we find that there are two beds, okay, I'm trying to use, you know, a certain language. This is not the right language. Okay, two beds are saying an angle theta gave birth to 7, and an angle 65 gave birth to 5. So this means these are two beds that has got a mother and the child. Okay, fine. So in the case of two beds, you use what you call sine. But in the case of one bed, okay, in the case of one bed, you use what you call cosine. Okay, that's what you need to do. So here in this question, we saw that there is two beds, so that means we are using the sine rule. Okay, all right, whereby we are comparing bed 1 being equivalent to bed 2. Very simple. Okay, So let us do that. So the sine rule is saying A over sine A is equals to B over sine of B. So you would find this is base 1 and this is base 2. Okay, so base 1 and base 2, we have them here. What was base 1? We can say maybe theta giving to 7 is base 1, and then 65 giving to 5 is base 2. I just want you to be looking at these arrows. So if there's 2 arrows inside your triangle which are matching mother to son, that is fine. That means maybe you have had them all right. Okay, so what you need to do now is to say son over mother, son over sine of mother. Very simple. Okay, so this means here we have son 7 over, okay, let me just do it according to what the diagram is saying. So son is A, let's say, and it is 5, so we put a 5 over the sine of the angle, which is sine of 65. Okay, and then here we have son. Okay, instead of B we have C, right? So I can even put a C if you want mine. I can put a C here so that they can match with the diagram. Okay, so we have here sin C is 7 over the sine, okay, now of theta. Okay, now when you are here, solve, because you are done substituting. Okay, what you're when you're solving, I said you just use your mathematical gymnastics. Okay, so what I have here is I'm going to just put everything into the calculator first so that I don't deal with, you know, those trig ratios. So what is sine of 65? Sine 65 equals, I'm going to round off to 2 decimal places. So I have 5 over sine 65 is 0, 91. Okay, I put a 9 and a 1, and then I say equals. Now 7 over sine theta. I can't remove sine at the moment because I can't put sine theta into the calculator, so I have to solve with that sine through and through. So when we have fractions, we cross multiply, so we will have 5 sine theta is equal to 7 multiplied by 0.91. Okay, and then so to remove coefficients here, it's wise for us to remove this 5 by dividing both sides, okay, by 5, and then we know that we are left with sine theta being equal to, let us put all these values into the calculator. First we put the fraction sign, and then we put a 7 multiplied by 0.9 1, okay, and then we go down and put the 5. Our answer then becomes 1,274. So here we have 1,274. So that means our question has got a problem somewhere. Okay, so here, very sorry for that, because this is a self-made question. I didn't just take it or adapt it from the book, so I made a mistake on that. Okay, so what we are going to do is our sign must cross the equal sign, and we'll have theta left alone, all right, and then we say equals, and then here we have second function of sine, and then 1,274. all right, what I want you to do, guys, is just to forgive me here, because once that one is 65, that means our triangle will not work. So maybe it was going to be very simple if 65 was corresponding to 7. So this means here my answer will not come out. I'll just show you from the calculator, because sine cannot be greater than 1, I mean the arc sine of an angle cannot be greater than 1 or less than -1. So this means here my calculator will just say error. But in the case where it's an exam type question, automatically it won't say error. So we just do the stages so that you will not have questions. So we put second function, and then we press sine, that second function of sine, and then 1 comma 274. Okay, and then you just say equals. So here though it is giving me some values, this is not exactly true because it has got an I in front of it to show this is not a real number. So otherwise for now we can leave it here, right? Fine, let's go to the next question. So the next question here is reading find x when you're given a triangle like this one. Okay, don't forget the rules because they are the most important thing. Okay, so let's take our rules with us, put them into the bag and go. Okay, so it is saying find x. First thing is to name the triangle. Okay, automatically we know that if we have a, this becomes small letter a, this becomes small letter c for the sides, and small letter b for the sides. That's naming. All angles are named, all sides are named. And then we move to finding the formula. We find the formula, and you know what determines the formula is the babies. All right, so 75 is going to give birth to x. 5, how come we have 5 without the mother? So meaning to say we cannot have birth here. We don't know where 5 came from. Maybe 5 was adopted, is that right? So 5 was adopted, it was not given birth. And then 7 was adopted, no birth again, because there is no mother here for 7 and there is no mother here for 5. So we just say no, there is only one birth. Okay, so as we agreed in the previous example, we said where there is only one birth, we use what we call the cosine rule. Okay, so what does the cosine rule state? In our previous video we tried to summarize the cosine rule so that you won't have many rules but only one. We said that you write it as follows. Okay, you write it as cos of the given angle, and the given angle is 75. So yes, cos of A, let's say, is equals to, and then I said from the given angle you put a full stop, and then you put that queen's crown, is that right? And then the sides that you are going to touch should be added. Okay, the sides that you are going to touch should be added. Okay, so meaning to say we are adding the side C and the side B. So B squared plus C squared, and then we subtracted the side that was not touched, which is A squared. Remember, all these should go over to they must go over 2, and then you bring these ones down again, right? The ones that we're adding should come down, so you have 2B and then C sorted. So next, after writing the formula, is you now substituting to solve. What is cos A? It's cos 75, and then you say equals, what is B squared? So what is B? B is now replaced by 7 squared, and then we say plus. What is C? C is replaced by 5, so we put 5 squared, and then minus. What is A? On A we see there is an x there, so we put what was given in the question. That's what you call substitution. And then we say all over 2 is a 2 is a constant of the formula. You must bring that 2 always. And then what is b? As we agreed, b is 7, and then c is 5. Okay, now we are done. Guys, when you are here, after substitution, you are going the free dance, as I said. Okay, so meaning to say you are going to be using your own way of solving it. Okay, so for me, I'm going to find what is cos of 75. That's the first thing I'm going to do. So I need cos 75, and I got the answer here is 0.26. Let me say, so I have 0.26, and then I say equals. Okay, let me just simplify the numerator and the denominator. 7 squared plus 5 squared, so we have 7 squared plus 5 squared. Okay, we get 74, and we are going to put 74 here, minus x to the power 2 all over. Now 2 multiplied by 7 by 5, we have 2 times 7, and then times 5, we get a 70. So we are going to put a 70 under here. Super. Okay, then now what is going to be the next stage? The next stage is solving equations. This is done simply by making both sides fractions, okay, and cross multiplying. So we will find out that we will have this side 74 minus x to the power 2 is equals to 70 multiplied by 0.26. Okay, and then what is 74 minus x squared? Okay, I just want to do something short here. I have 74 minus x squared equals, so when I say 70 multiplied by 0.26, 0.26 multiplied by 70, I get 18.2. So this gives me 18.2. All right, let us collect like terms. 74 minus 18.2 equals, when x crosses the equal sign, the sign must change to a positive, so we'll have x squared here, and this means all right, let me just create space here. This means what I'll be having here is an equivalence of okay, let us do 74 minus 18.2. okay, 74 minus 18.2, we get 55.8. okay, so we have 55.8 is equals to x squared. You know, removing squares by putting square roots both sides, what do we get here? We get x equals to square root of this answer. Okay, so we have square root of the answer, we get 8.6. so this means x is approximately equal to 8.6. the answer was in meters, so I just put meters, and this marks the end of it. So this is the answer that was expected from us. Okay, so this becomes the answer, right? Sorted. Now let us move to the next question. You know, my time is flying here. All right, the next question is also going to be named. Remember, before you go to any question, do the right thing of just taking your your rules and, you know, taking them there. So meaning to say, here we have our stages. Is that right? Let me just take them and draw them a little bit down here. Okay, so that maybe we can have our space workable. All right, let us do the naming very quickly. Who is going to give birth here? Theta giving birth to 11. There is also this guy is adopted, and also this guy is adopted. So what we need to do is very simple. This means we are having only one birth. One birth leads to cos. Is that right? Or a cosine rule. Let us put down the cosine rule. It starts from the angle, alright? That's given, and then it goes to the sides. That's very simple. Okay, so meaning to say we need to write cos of C. Cos of C equals 13 squared plus 15 squared. You know, I didn't put it, okay, so let me just make it theta. I didn't do, you know, the longer channel, and then minus 11 squared, all this over 2 by, we bring down 13, and then we bring down 15. Now when we are solving, means we have cos of theta equivalent to what is 13 squared plus 15 squared. I put 15 to the power 2 plus 13 to the power 2, and I get 394. So that's, I have 394 minus 11 squared is 121 all over, and then I have 2 multiplied by 13 multiplied by 15, 2 times 13 times 15, okay, 319. Okay, when I'm here, you know, we are going stage by stage, okay? So when I'm here, the next stage is I have to put cos of theta and then all these into the calculator so that they can give me one value. Fractional sign there, 394 minus 121, and then all over 390, and we get 0.7. Okay, so this means the answer becomes 0.7. Alright, what's next? I must take now cos to cross the equal sign and become its second function. That means I will have theta left alone equals second function of cos into 0.7, and then I have here theta equals arc cos 0.7 is okay, said arc cos, sorry, I made a mistake here, arc cos of 0.7, then I close it, I get 45.57 degrees. Okay, so that means 45.57, you know, to 2 decimal places. Okay, remember it was in degrees, that's to 2 decimal places. Don't worry about it. Okay, so this marks the end of it. Okay, guys, I believe and hope that you have come to an understanding of how do we choose between the formula that I have been talking about. Okay, so as I said, that there is the trig ratio, Pythagoras, sine and cosine. Now I believe by, you know, doing these questions, I believe that you now know when to use the trig ratio and when to use the Pythagoras, and then when to use the sine and when to use the cosine. Remember that sine and cosine works only with non-right angled, and then trig ratio and Pythagoras, they work only with right angles. With these guys, I know that you have all the bolts and nuts of, you know, right angled of all, let me just say, of all triangles. So what you have to do is just to practice past exam questions, and then just get yourself geared for that examination. Wish you good luck. Let us meet next time in the next topic. Sharp, sharp.